Welcome to my YouTube channel PGK Kadam Academy. Dear friends, this video is on the easy way to find the eigenvalues and eigenvectors. So friends, matrix, we are using the values to find the matrix. Here, the 2 by 2 matrix we are using. Dear friend, it's a very easy way to find the eigenvalues and eigenvectors of the matrix is given 7, 3 and 3 minus 1. How to find? There's few steps are defined. Before that, each matrix having the dimension, rows defined by the rows and column. This matrix is of dimension of the 2 by 2 matrix. This m by m is the to define this any matrix, the rows m into rows and column m. So friends, the steps or process to find or solve the eigenvalues, and it is represented by here that lambda. So friend, and the corresponding eigenvectors where to find out. This xj matrix or the eigenvectors where to find out. Of a matrix m by m matrix, it is the given to you or any matrix which we have to find out the eigenvalues and eigenvector of the matrix. So dear friend, the first step is to multiply an m by m identity matrix with the same dimension as a matrix which have with the A matrix by the scalar this lambda. Lambda is what? It's the eigenvalue where to find out. This identity matrix means what? Where this diagonally these all values are 1 and remaining values are 0. If the matrix of 3 by 3, this matrix is 2 by 2. Why? Because A is 2 by 2. Here 1 0 0 0 0 0 1 0 0 0 1. If the matrix is of 3 by 3, so friend, this matrix is of 2 by 2. We have to multiply the identity matrix by scalar lambda. The next step is what? We have to subtract the identity matrix multiple from the matrix A. From this matrix, we have to subtract. And after that, next step, we have to find out the determinant. We have to determinant of this subtraction and this total term difference. Okay. So next step, to solve the values lambda that satisfy the equation. So this lambda that satisfy equation we obtained from the last step, 3 step. So from this we have to find out the values, and that values are nothing but your eigenvalues. After that, for each eigenvalues corresponding vector to each eigenvalues, we have to find the vector. The value we have to consider the highest value, and after that we have to find out the respective vector of that value. How we have to obtain all the steps we have learned. So friends, step 1, multiply an m by m matrix, that identity matrix by the scalar. Here is the scalar value, that is the lambda. It multiplied with the this identity matrix 1 0 0 1. Return lambda 0 0 lambda. The next step we have to do the subtract the identity matrix multiple from the matrix A. Here matrix A is this one. We're subtracting this multiple, identity matrix multiple from this matrix A, 7 3 3 minus 1 minus lambda 0 0 lambda. After this, continue with the step 2. We're taking this difference subtraction here. So particularly how to do the subtraction of this matrix? Here in the subtraction of matrix, while doing the subtraction, we have to do this like this. Okay, 7 minus lambda, 3 minus 0. We have to difference of the each term in that matrix because the matrix must be same dimensions. Okay, so this 7 minus lambda, 3 minus 0, 3 minus 0 minus 1 minus lambda. So after rewriting this matrix, it is written like this: 7 minus lambda, 3 and minus 1 minus lambda. So friend, This is the step 2. In step 3, what we have to find out? We have to find out the determinant of this matrix and the difference. The determinant we have to find out for this one. So this determinant we have to find for this. It is CR. It is represented like this. Matrix is represented. Eh? How the matrix is represented and how the determinant is difference, that you must know. We are finding the value of that matrix, the scalar value we are getting. So friend, this find the determinant step 3. How to find? Just solving this determinant matrix. Here 7 minus lambda is multiplied with this one. So this is the step written here. This cross multiplication will be there, and 3 into 3. So this first cross multiplication, second cross multiplication, and after simplifying this one, minus 7, correct? This minus 7. After that minus this minus 7 lambda. After that this minus minus get plus lambda, and this minus minus get plus lambda square, and minus 3 into 3, 9. Next step is what? This simplifying this equation, we are rewriting this lambda square minus 6 lambda minus 16. So this equation we obtained, lambda square minus 6 lambda minus 16 is equal to 0. We have to go toward the step number 4 to find the values solution of this equation. To find this, solve these values of lambda to satisfy that equation. So this equation, what? Lambda square minus 6 lambda minus 16 is equal to 0. To satisfy this equation, so this equation is what? This is the quadratic equation, linear equation. So this friend here, quadratic equation solution can be obtained by using this formula. Lambda is equal to minus b plus minus under root of b square minus 4ac upon 2a. Here the coefficient is a, here the coefficient is b, and this is coefficient is c. This is a constant, not a coefficient. This is the constant c. So friend, by using this we can find out, or as this equation is very simple, we can find out these values like this also, the lambda minus 8 or lambda minus 2. So values become the lambda 1. The first value is 8 and second value becomes a minus 2. So these two values are nothing but the eigenvalues of the matrix A. So friends, once we find out the eigenvalues of matrix A, so these two values are different values. So one by one we have to, as this 8 is very large value than this 2, the first we have to find out 2 with A. So we have to find out, we'll just find out the eigenvalues. Now we have to find out the eigenvectors. How to find out the eigenvectors? Mathematical. Before that, eigenvalue is what? It's a mathematical concept used in the linear algebra. Is a scalar that represent how the linear transformation affects the vector. That will affect the vector. And this eigenvalue are important in determining the variance of the data in each principal component also. And this eigenvalue, friends, very useful in other machine learning algorithms also, like a linear regression, to determine the optimal parameters of the model. So friend, after this step 5, to get the eigenvectors, solve the corresponding vector for that each lambda. This already we have solved here. This, for this lambda 1, 8 is equal to, we have to find the eigenvectors for this matrix A. So friend, to find this, put it the here lambda 8 in this matrix. The matrix become, this matrix become a new matrix. As the first matrix is were called A, we are calling this matrix as a B. Now what we have to solve this equation? B vector x is equal to 0. The B vector x is equal to 0, we have to find out minus 1, 3, 3, minus 9, x1, x2. This is the these two matrices were written here. This x1, x2 is nothing but our eigenvectors. Once you find out the values, how to find out these values? Just solving these equations. Just we are written here this matrix in this form. What we are doing here is the row reduction operation we are performing. Here, what operation we are performing? We are reducing this second number row R2 into 0. So it will be done like this. And what is the operation done here? 3 into R1 plus R2. So we'll get this R2 row become 0. So these two values are getting here, x1 coefficient -1 and x2 coefficient 3. So this is written like this minus x1 plus 3x2. We can also write this 3x2 is equal to x1. To continue with this term, here bx vector is equal to 0. We are written here continuation. The 3x2 is equal to x1. So putting the value of x2 1, we will get the value of x1 is 3. That x1 and x2 values are obtained here. These two values are nothing but our eigenvector for this matrix A. For this eigenvalues, this respective eigenvalue 8, we obtain this eigenvector x1, x2, the 3, 1. So friend, once we find out the eigenvalue and eigenvectors, this is for this first eigenvalue 8. Similar way, we can find out the lambda 2 minus 2. That is the second eigenvalue. But that answer is correct or not, how to check? We can check by this equation, that matrix A into this eigenvector, this eigenvalue into eigenvector. So for this first lambda 1, and this is the eigenvector, put this in this equation 7 3 3 minus 1, and that eigenvector is 3 1, which is equal to lambda is 8, 3 1 is the vector. So this multiplying this 3 into 7, we'll get this 3 into 1, we'll get the 24, 21 plus 3, that 24, and 3 into 3, 9 minus 1, 8. Okay, this is here check that both the sides are equal. So that will be, this means this lambda 8 is correct. Okay, this is the first value we are check for this eigenvalue and eigenvectors. So friends, next we have to go for the similarly the concept of the eigenvectors. Eigenvectors are nothing but the mathematical concept used in a linear algebra. And an eigenvector is a vector that when the linear transformation is applied to it is scaled by the constant factors. So this eigenvector is scaled so that we can get the original value. So friend, now the step 5 again we are repeating here. For this lambda 2 is equal to -2. Similar steps just for the before we are solving here for this eigenvalues and with this matrix A. So friend, here putting the as a lambda, here -2 were kept here values in this matrix 7 minus 2 minus 2, 7 minus -2, 3 3, again here -1 minus 2. So what will the next value? 3 9 3 3 1. Friend, this is the matrix B we are calling, and for this solve the matrix B with the vector x. So we'll get bx vector 0. So continue with this bx. How to solve? Again the row operation we are performing for this matrix. Okay, so this to perform the row operation here, row reduction operation. So we are reducing now this first number row, because x1 x2 were performed for the first, already we are calculated. Now we have to perform on this row, that r1. So -3 r2 plus r1. So in this case -3 r2 here plus r1, we have to do it row operations. So what we get, that will be here, get the values 0 0 in this first row after the row reduction operation. Then remaining will be the 3 into 1. These are the values are x1 x2. Now this 3x1 plus x2 is equal to 0 we are getting from this matrix. Okay, these values of x1 x2 putting here, the x2 is equal to -3 x1 we are getting here. Continue with this bx vector 0. So that is the obtained from the last equation. So this one is the x2 is equal to minus 3x. We can rewrite this equation and we can write here x2 is equal to minus 3x1. From this we can write if x1 is 1, so we'll get the x2 is minus 3. Putting here 1, we get the minus 3. So this will be nothing but your eigenvectors of the matrix A, and for eigenvalue minus 2, lambda 2 is minus 2, that eigenvectors are x1, x2, that 1 and minus 3, 1 and minus 3. And for checking this answer is correct or not, a v is equal to lambda into v. V is the what eigenvectors, and here A is the original matrix for which we are finding the eigenvalues and eigenvectors, and lambda is the eigenvalue. So friend, putting this in this equation, the matrix A and 1 and minus 3 into is equal to minus 2 into 1 minus 3. So checking this answer, this 7 into 1, 3 into 3 minus 9, so minus 2, it is correct. And here 3 into 1 minus 1 into 3, that is the 6. And here on this side, left hand side and right hand side, the both the answers are correct. So it's a checking point, it's a perfect answer where calculator. Yes, successfully we are done. So thank you for watching my video. If you're not subscribed, please subscribe my channel for more and more video on this mathematical tools and the machine learning.